So moment of inertia is always of a body about an axis. Let's understand this by an example. Let us say there are three particles now, 1 kg, 2 kg and 3 kg. These are point masses which are situated at the vertices of a equilateral triangle of side 10 meter. What we have to do is, we are supposed to find what is moment of inertia of this system of these three particles about the x dash axis, what is moment of inertia about y dash axis, and what is moment of inertia about z dash axis. So we have to find the moment of inertia of these three particles about these three axes. We know that is moment of inertia is always of a body about an axis, of a particle about an axis. When we say Ixx dash, so our concentration is going to be on this. Let's say this is now the axis. So put more emphasis on this axis, that this is the axis rotation, because generally the students, they get confused about the x and y coordinates. It is not the x and y coordinates which will be bothered about. We are more bothered about what is the distance of particle from the axis. This is going to give you the moment of inertia as mr square. That is what we have done. So over here, moment of inertia of 1 kg body is 1 into, what is the distance of this from this axis? It is 0 only. Of 2 kg, 2 into, this is on the axis only. You can always assume the axis to be a kind of a river, and this particle, let's say a person who is there. So this person of 2 kg is on the axis only, it is within the river. So 2 into 0 square plus 3 into, when it comes to 3, many times students say the distance of this 3 kg particle from this axis is 10 meter. We are not bothered about the origin, we are bothered about the axis. This is an infinite line. This extends to infinity, this extends to infinity. So if this is a river, this is a person, now how far is this person from the river? It is only this distance, this is the distance. So obviously, when this is equilateral triangle, so this is going to be equal to 60 degree. All the angles are going to 60 degree. This is going to be 10 cos 60 and this is going to be 10 sin 60. So this is going to be 3 into 10 sin 60 degree, m into r square. You can get the answer. If you have to find the moment of inertia about this axis, now concentrate on this axis. It is, we say Iyv dash. Take one particle at a time. Moment of inertia of 1 kg about this axis is 1 into 0 square. It is on the axis itself. 2. Now this 2 kg is, this 2 kg point is at a distance of 10 meter from this axis. Perpendicular distance is going to be 10 meter. So plus 2 into 10 square plus 3 into, what is the distance of this particle from this axis? What is the distance of this man from this river? This is the distance, perpendicular distance. What is that? That is 3 into, if this is 10, so this is going to 10 cos 60, so this is also going to 10 cos 60. 3 into 10 cos 60 square, and we can get the answer. Now comes Izz dash. Moment of inertia of these three particles about an axis, that is zz dash axis over here. This axis. So it is once again going to be 1 into 0 square. So what is the distance of this 2 kg from this axis? It is 10 meter only. So plus 2 into 10 square. Now what is the distance of this from this axis? If there is confusion, let's say we remove it. Now what is the distance? We are not bothered about the x and y. What is the distance of this particle from this axis? It is obviously the shortest, is 10 meter only. So it is going to be plus 3 into 10 square, and we can get the answer. Obviously, when we say the moment of inertia about axis is mr square, so unit say is going to be kilogram meter square, and this is a scalar quantity. This is going to be a scalar quantity. Moment of inertia of a body about an axis, that is scalar quantity, and the units, they are kilogram meter square. And if you talk about dimensions, it is going to be m1 l2 t0. That is going to be the dimensional formula for moment of inertia.